Okay, so Chapter 1, Section 3, ordering real numbers is really just about comparing irrational and real irrational numbers. Okay, if you remember from the last lesson, we classified numbers in a way where rational numbers are real and irrational numbers are real. All right, we can use them; they exist in the world. So here we're ordering real numbers in both rational and irrational. That's rational and irrational. So that's new for 8th grade, and we're getting into standard 8.NS.2 specific to approximating irrational numbers and locating them on a number line diagram. So this first example, we have square root of 3 plus 5 and 3 plus the square root of 5. We need to figure out if this first one, square root of 3 plus 5, is less than, greater than, or equal to this other expression, 3 plus the square root of 5. So I have this written here, but what I want to point out is I'm going to go ahead and guess that the side here, this side that has a 5 is going to be greater than this side that has a 3. So that's kind of already a dead giveaway, but what they're trying to get us to explain, to understand, is that if we approximate the square root of 3 and then approximate the square root of 5, we're going to get a much more specific couple of numbers to compare, and that's where we're going to get into knowing specifically which side is less than, greater than, or equal. So first, we need to approximate the square root of 3. Now, they say the square root of 3 is going to be between 1 and 2. And they know that because 1 times 1 is 1, 2 times 2 is 4, and 3 times 3 is 9. And why that matters is because the square root of 1 is going to be 1. The square root of 4 is going to be 2. And the square root of 9 is going to be 3. All right? So these connect. These are related. So if we're trying to find the square root of 3, it's probably going to be somewhere between 1 and 2. Because we're trying to find the square root of 3. So it's not going to be more than 2, right? So that's kind of where they're getting at with this. And then if we try to approximate the square root of 5, we're going to find out that if the square root of 3 is somewhere here, then the square root of 5 is going to be somewhere here. And just using some logic, the square root of 5 is going to be more, yeah? And the square root of 3 is going to be less. So that's where we have to do some guessing and checking, all right? So if the square root of 3 is somewhere between 1 and 2, okay, and the square root of 5 is somewhere between 2 and 3, closer to 2. I mean, they're both pretty close to 2, you know? Then that's about 2 plus 5, which is 7, yeah? So that's square root of 3 plus 5. That's about 7. And 3 plus the square root of 5, which is close to 2. That's going to be 3 plus about 2. That's going to be about 5. So what we're talking here is if the square root of 5 is about 2, and the square root of 3 is about 2, then 3 plus 2 is 5, and 2 plus 5 is 7. So which one's going to be more? There's a good chance that we're going to want the less than sign. All right? So we're approximating these square roots. Cool? So that's kind of what we're talking about here. Now, the next page here talks about ordering real numbers, where you have to order the square root of 22, pi plus 1, and 4.5 from least, the smallest number, to greatest, the highest number. So we're going to take each one and figure out what the square root of 22 is, right, approximately. What is pi plus 1, approximately, and what is 4.5? Well, 4.5 is 4.5. So it's really just figuring out what the square root of 22 is, because pi is 3.14, add 1, and it's 4.14. So that's not really too complicated. It's really this square root of 22 that we need to figure out. So let's figure out where square root of 22 is. The book's telling us it's between 4 and 5. Well, what's 4 squared? 16. And what's 5 squared? 25. So the square root of 22, yeah, that's gonna be somewhere between 4 and 5. The square, to be more specific, the square root of 16 is 4, and the square root of 25 is 5. So the square root of 22, yeah, that's gonna be probably closer to 5 than to 4, okay? But it's definitely going to be somewhere in between. So they do some guessing and checking by taking 4.5 and multiplying it by itself. 4 times 5 times 4 times 5 is going to equal 20.25. All right? 5 times 5 is 22, and then 4 times 5 is 20. 4, 16, 17, 18, 5, 2, 10, 1, decimal, decimal, and it looks like I did not add that 1. That carried. All right, so 20.25. So 4.5 squared is 20.25. Yeah, that's pretty close to 22. But notice what happens when we do 4.6, which is between 4 and 5, but just a little closer to 5. We get 21.16, which is closer to 22. And then we do 4.7, which gets us 22.09, and that is more than the square root of 22, so that's not going to work. We want to get as close as we can without going over. And 4.8, obviously, is way too far. So 4.7, they say, is an approximate value. I would... yes, technically on a number line it is closest. I would argue that going underneath and getting as close as you can without going over is a best practice, but there are people who just say any number that's closest, and that's fine too. Cool? Cool. So then we plot these things on a number line so that 4.7 squared is 22.09, so 22.09 is kind of what we're looking. That is square root of 22 is 4.7, so we're looking for 4.7. 4.7 is as close as you're going to get to the square root of 22. So 4.7 is right here. 4.5 is here, and then the 4.14, which is 3.14 plus 1, is here on the number line. So we can order them from least, the lowest number, to greatest. And that would be the solution to this question, to this request. So that's what we're doing when we're ordering real numbers. And really what it comes down to is, do you know how to approximate the square root of an irrational number? Well, find the irrational number by approximating the square root. Cool? Independent practice, ordering these numbers, is just practicing finding square roots, approximating, and ordering them. And that's it.